This video will describe the maximization of an individual's healthy eating habits and was produced for Professor Hodgson's intermediate microeconomic theory class at St Olaf College. Poor nutrition is a major issue within the United States. The Center for Disease Control estimates that roughly 1/3, or 78.6 million Americans, are obese. With such a huge portion of the population struggling with obesity and poor nutrition, many health complications have arisen such as heart disease, stroke, and diabetes, resulting in roughly $147 billion in annual obesity-related medical expenses. That's almost 1% of America's annual GDP. As nutritionists, doctors, and the government move forward, there is much to learn about increasing healthy eating patterns. Our model looks to understand the influences on healthy eating behaviors in the hopes of improving nutritional consumption habits and reducing obesity within the United States. We chose nutritional density of food consumed per day as our choice variable to help maximize an individual's healthy eating habits. Nutritional density is the abstract measure used to determine how nutritious a food item is and is equivalent to nutritional intake. For example, Cheerios has a higher nutritional density than Fruit Loops because it contains more nutrients and less sugars. We will use nutritional density to manipulate the three main components of our model: health, effort or expense, and palatability or taste. In the model, we also included several other exogenous variables such as weight, metabolism, calories consumed per day, genetic risk of disease, and availability of nutritional food. Let's examine the curvature of these relationships. Figure 1 explains how health benefit experiences diminishing marginal returns because as you increase your daily intake of nutritional food, your overall health will increase. However, you can only consume so much nutrition per day, and so the added health benefits from higher intakes of nutrition decreases. For example, suppose that you only consume Fruit Loops for your diet. Then you would receive a low amount of health benefit compared to someone who only eats Cheerios. But then there's the individual who only eats whole grain oats, who has a higher nutritional intake but receives less additional health benefit overall. Figure 2 explains how consumer effort experiences increasing marginal costs because nutritional food is often more expensive and more difficult to obtain than non-nutritional food, such as fast food. The greater an individual's nutritional intake, the more effort they must exert in order to obtain those nutritious foods. Consider a trip to the local fast food store. It takes minimal effort to travel there, because they're on every street corner, and fast food is cheap. But a trip to the nearest organic grocery store most likely takes longer to travel and is much more expensive. Thus, an increase in nutritional density requires an increase in effort and expense. Figure 3 explains how more nutritional foods in general taste worse than unhealthy foods. Even though some foods may have a bad taste, that taste is still existent and therefore palatability is modeled with an asymptotical inverse relationship to nutritional density. For example, recall Fruit Loops, Cheerios, and whole grain oats. The additional palatability from eating Fruit Loops over Cheerios is greater than the additional palatability from eating Cheerios over whole grain oats. Moving on from curvature, by utilizing comparative statics with our model, we can determine the effects of an increase in the availability of nutritional food on the three main components of our model. Returning to our model, we can observe that the availability of food will only affect the effort or expense located here. Therefore, we only need to consider this relationship in comparative statics. Returning to figure 2, increasing the availability of nutritional food will decrease the amount of effort required to obtain said food, therefore rotating the curve down and out. This means that the marginal effort, or the slope of the tangent line on any point of this graph, will decrease. To maximize health utility, we must find the specific amount of nutritional density per day where the marginal benefits are equal to the marginal costs. If our marginal effort decreases, then to counterbalance the decrease in marginal costs, we can 1. Decrease the marginal benefit by decreasing the marginal health benefit, 2. Increase the marginal cost by increasing the marginal effort, or 3. Increase the marginal cost by increasing the marginal palatability. Let's observe these three changes graphically. Firstly, to decrease the marginal health benefit, or the slope of the purple line, we must increase the nutritional density of food, such as switching from Fruit Loops to whole grain oats. Secondly, to increase the marginal effort, or the slope of the pink line, we must increase the nutritional density of food, such as switching from fast food to organic groceries. Finally, to increase the marginal palatability, or the slope of the green line, we must increase the nutritional density of food similar to before in switching from Fruit Loops to whole grain oats. Note that in an inverse relationship such as this, increasing the slope will cause it to become more flat. The results of our comparative statics demonstrate that an increase in the availability of nutritional food leads to an increase in the nutritional density consumed per day. By increasing the nutritional intake of a population, we can directly decrease the obesity rate. Connecting our findings to others, a study done by Walker, Keene, and Burke found that there is persisting unequal access to nutritional food within the U.S., especially in impoverished and racially diverse regions where access to supermarkets and locally grown foods is particularly low. This unequal access makes it difficult for individuals in this area to acquire nutritional food, and so their overall health is poor. This correlates to our model by providing data that supports our assumption that effort has a positive slope. Our model has taught us that increasing the availability of nutritional food will lead to an increase in overall health and nutritional density consumption, therefore lowering obesity rates in America. This model can be utilized by the government to estimate the nutritional availability and overall health utility of different neighborhoods. The government can then determine which communities do not have access to the optimal amount of nutritional density and then focus on subsidizing local farmers and markets to sell organic and nutritional foods in those communities in an effort to increase nutritional intake and lower obesity. Thank you.